We are given the equation initial kinetic energy plus initial potential energy plus work is equal to final kinetic energy plus final potential energy plus change in thermal energy. For this problem, start with the equation above, which is the equation I just stated. A small block of mass m is hung from a rope and released. It begins to move downward, pulling a larger mass m along a horizontal surface with the sum kinetic friction given by the coefficient of friction. Derive the block's velocity just before it hits the ground in terms of the mass h, coefficient of kinetic energy, and any other relevant constants. So here's an image of what's happening. As you can see, this is the block which is dragging this block down as it falls down. This is the height of how far this block is dropping down, and this is the coefficient of kinetic energy. So let's first start by breaking down each variable, and then at the end we'll plug back each variable in and solve for the velocity before it hits the ground. So let's start with the work. Work is, as we know, work is equal to force times displacement. And then we also know force is equal to the coefficient of kinetic energy times mass times mg. Alright, so now we know that velocity and the work is equal to the coefficient of kinetic energy mg times d. And then we know initial kinetic energy is equal to 1/2 mv squared. And then we also know that the final velocity is equal to mgh. And since also we are dealing with the velocity before the block hits the ground, we actually know that the initial velocity, the final kinetic energy, and the change in thermal energy is all irrelevant because that has nothing to do with the problem. Therefore, all of these values will equal 0. Also, here's a force diagram of what's happening on the block M. The forces are affected on the coefficient of kinetic energy, the mass times gravity, and then the normal force. So now let's just plug in all the values found in the initial equation given to us, which is the same equation up here. So as we said, initial kinetic energy is 1/2 mv squared. Then initial potential energy will just be 0. And then the work will be equal to coefficient of kinetic energy times mg times displacement. And then this will all equal 0, which is the final kinetic energy, plus mgh plus 0. So now what we have to do now is solve for v. So then after solving for v, we will get v equals square root of 2 times mgh minus the coefficient of kinetic energy, mg times displacement. And this will all be over m. And then that will be how we derive the velocity before it hits the block M hits the ground.